So we know that half-life is the time taken for half of a radioactive substance to decay. Okay, let's say we have got a certain amount, the certain mass of something. So let's say the mass is 100, right? The mass is 100. So when this mass drops by half, it is going to go to 50. Now at the beginning, you consider the time to be 0. Okay, the time is 0 there. So what this is going to give us is that, let's say the half-life is 6 seconds. So for us to move from 100 to a 50, this is going to be 6 seconds, because that is the half-life. And then from 50, if I want to divide 50 by 2, that is going to give us a 25. That will be the next. And the time taken from you to move from 50 to 25, now to this 6 add another 6, because half-life is 6, that is going to be 12. And then the 25 still divided by 2, that is going to give us 12.5, the half-life here. So to 12 again add the half-life, that is the time taken for half of the substance to decay, that is going to be 18. 12.5 again, if we divide by 2, to give us 6.25. So again, to this add the half-lives, 18 plus 6, that is going to be 24. So this is the diagram that we're able to, this is the data that we're able to collect. So from here, remember, we can draw the curve, and it is very important for you to know how to make this curve, because they do ask. We have got time this side, and then we have got the mass or the amount this side. So time, the smallest we have is 0, the next we have 6, then we have 12, and then we have 18, then we have 24. Now for the mass, it goes, the highest we have is 100. So I want to make a scale that is going to be convenient for my working, so I can move in tens. Let's say this is 10, this is going to be 20, 30, 40, 50, 60. It will not fit going on top, so let me try to remove. Okay, you want us to move in that? So what I'm saying is, I'm looking at these values. So make sure that you pick a nice scale, because if you don't, there are some values that are going to be very difficult for you to plot. So 50, 60, 70, 80, 90, and then 100 on top there. Now remember, the first was 100 and the time was 0. So you can start plotting 0, 100, that's there. Then you have got 50, 6. This is going to be here. You have got 25. So 25 is going to be somewhere here on that middle. 25, 12. This is going to be somewhere here. And then you have got 12.5. So if this is 10, this is 20. 15 is going to be on the middle here. So 12.5 is a bit of below 15, okay? So there, so 12.5, 18. So it will be a bit of down here. And then you have got 6.25, 24. So if this is 10, the half is going to give us a 5 somewhere here. So just a bit above of 5, that is where we're going to find 6.25. So the graph is moving something like this. So just make sure that it is a bit, try to be as smooth as you can. Though it's not too smooth, but we need to try to make it as smooth as possible. Okay, so something like that, that is how we are going to write it. So that would be the diagram. Now I want to show you something again. Remember, this was representing the amount, and then this was representing the time. Now let's calculate how many half lives are here. How many half lives are here? When we are just starting, you can see the time is 0, right? Meaning that also the half life is 0. But when we moved from 100 to 50, there is only one half life here. Okay, only one half life. And then when we moved from 50 to 25, there is another half-life. So one half-life plus the other half-life, that is going to give us two half-lives. And then here this is going to be three half-lives, and then this is going to be four half-lives. Do you get that? Is that okay? So from 100 to 50, this is the first half-life. From 50 to 25, that's the second. 25 to 12, that's the third, and then that's the fourth. Do you get that now? Okay, so we can calculate the half-life from the equation. Amount is equal to initial amount multiplied by 1 over 2, and then this is raised to the power t divided by t, like that. T over t. Now what does the capital T represent and what does the small t represent? Okay, so this small t that you're able to see, it is representing how long something would take to be reduced. For example, how long will it take for 100 of this to go to 25? That is how long, huh? So the time it takes, you can see this is 12 seconds. That is the t. Now to avoid this confusion, I'm going to write. You can see it. Can you see it now? Eyo ndembele kofi. So this is going to be capital T. Now I'm going to put capital T on top because it's representing the time for something, and then divided by half-life. So this small t, remember, is representing half-life. Now half-life, will basically write it as t with a 1 over 2 down here. Okay. Now this A0 is representing, the A0 is representing the initial amount. Initial amount. And then A is going to represent where you've reached, the amount that you have. So let's say we are moving from 100, that's the initial amount, to 25. So meaning that A is going to be 25. A0, that's the initial amount, is going to be 100. And then multiply by 1 over 2. And then to the power. Okay, now we want the half-life, isn't it? We don't know the half-life, but we know that it is taking. Okay, let's say we know the half-life. We know the half-life. The half-life in this question is 6. Now I want to find out the time is going to take for this amount to reduce from 100 to a 25. So I'm going to say t divided by, where the small t, I'm going to put the half-life, that is a 6. So I'll divide both sides by 100, like that. 25 into 25 is 1. 25 into 100 is 4. So this will also cancel. So this is going to give us 1 over 4, and that is going to be equal to 1 over 2 to the power t over 6. So here you don't multiply this 100 with what is inside, because what is inside has got a power. Now you know 4 is the same as 2 squared, so this is going to be 1 over 2 squared, and 1 is the same as 1 squared, or 1 to the 1 is the same as 1 to the power anything. So from here I'm going to write this as 1 over 2 in brackets, because they both have a power 2. I'll put power 2 there, and that is going to be equal to 1 over 2. Then we're going to say t over 6. Since we can see the bases are the same, just equate the powers. You can see they all have the base 1 over 2. So equate the power. So we're going to say 2 is equal to t over 6. So for us to find t is going to be 2 multiplied by 6, meaning that t is going to be 12 seconds or 12 whatsoever. This is the 12 that we're able to see here. So you can use this formula to be able to calculate even what you don't know. Okay, any quantity that you might not know, you can use the same formula. Is that okay? It was just okay. I think it was just on the punching something there. So the formula is just okay. So let's start with this one. The half-life of blue radioactive substance located somewhere deep inside the lake is 7 weeks. So they've given you the half-life. So T 1 over 2, this is 7 weeks. How long would it take for 900 kg of it to be, this is supposed to be reduced to 10 kg? So you can see the initial amount, that's the one we are starting with. They've given us to be 900, and then you want it to reduce, so the final amount to 10 kg. So you want how long, so you want what? The time. You use the same formula. Amount is equal to initial amount multiplied by 1 over 2 to the power time over half-life. So the amount here is 10, initial amount is 900, and this is going to be 1, sorry, not equal to, we are multiplying 1 over 2 and then multiply by time over half-life. So we've been given the half-life, that is 7 weeks, right? But we don't know the time t. We know the half-life is 7. So make sure that you press the 7 on the right position. So divide both sides by a 900. So this will cancel with this 0 also cancel with that 0. So we're going to have 1 over 90. And that is going to be 1 over 2 to the power t over 7. Now this is physics. You can use a calculator. You see you have got a 90 here, and 90 you can't, it's not a square number, so meaning you can't write it as 1 as 2 to the power anything, because it's not a square number. So what I'll do is I'll just punch this on the calculator. That is 1 divided by 90. Just punch it on the calculator. We're going to get 0.01111, and that will be equal to, also punch 1 over 2 on the calculator. That will give you 0.5. So this 0.5 is raised to the power t over 7. Okay, like that. Now from here, I know it can seem to be a bit of big, unless if you are doing pure mathematics, but still, you see you have got a power like this. This is an index equation. You can't write these bases to be the same for you to be able to find the power. So what you do is you are going to introduce a logarithm. Okay, introduce a logarithm. Just bring all L O G this side, bring also L O G this side. At least just know this. Okay, so we're going to have put this in brackets, log of 0.0111 is equal to, now for a log, when you have got a power like this power can come in front of the log. So we're going to have t over 7 and then log of 0.5. Please, you need to just know this. Okay, this is all I want you to know. And then at this point where we've reached, we can now remove this. So divide both sides by this so that you just remain with t over 7. So say t over 7 is equal to, remember this side we have got this, so we're going to say log of 0.0111 divided by, remember we are dividing both sides by this, we also say log of 0 0.5. Now don't say log and log cancel, that is wrong. Okay, so what you do is just get your calculator as a log, just your calculator as a log. So you press where there is log and then you write 0.0111, you put it in brackets, and then again you say divided by, you press again log, you write 0 0.5. So this is going to give you 6.493. So for me to remain with t, which is the time, I'll multiply this 7 by this number. So the time then is going to be 45.45. This one is in weeks, meaning that also this answer is going to be in weeks. That is going to be the time. Is that okay? Is that okay? Yeah, it's normal. So you should just follow this tutorial again. If you have not understood on the log, just follow it again. You are going to see. I know this is not part of mathematics syllabus, but that is the only thing that you're able to use for this question. That's the only thing that you're able to use if it came. Okay? Let's try this one. The half-life of radium-224 is 3.66 days. What was the initial amount if 0.50 grams remains after 7.32 days? So let's collect the data here. We've been given the half-life t 1 over 2. That is the half-life they've told us is 3.66 days. Make sure that you take note of the units. The units for time should be matching. Then what was the original amount or the original mass? So we don't know A0. That's the initial, we don't know. If 0.5 remains, so what remains? A, that is the one we've been given, 0.50. And then we've been told after, so they've given us the time, that is capital T, it took for you to remain with that. That is 7.32, is also in days. So write the formula. A is A initial multiplied by 1 over 2 to the power capital T over half-life. Okay, like that. So the A we've been given is 0.5. A initial, that's the one we are trying to find. Then you have got 1 over 2 to the power capital T is 7.32. Small t is 3.66. So what is this going to give us? This will be 0.50 is equal to A0. We have got 1 over 2 is the same as 0.5. So what I'll do is I'll punch this on the calculator, 7.32 divided by 7.66, and that is going to be, oh sorry, not 7.66 by 3.66. This is going to give us a 2. So this is going to be 0.50 is equal to A0. Now 1 over 2 1 over 2 or 0.5 raised to the power 2, 0.5 raised to the power 2, that is going to give us 0.25, which is 1 over 4, 0.25. For me to remain with the initial, I'll divide both sides by 0.25, even this side by 0.25. So A initial is going to be 0.5 divided by 0.25, and that is going to give us 2. Remember, this is the initial amount, this is mass, so here mass has been given in grams, so meaning that even this one is going to be in grams. So this was the initial amount. Is this okay? Okay, let's try this. Carbon 14 has a half-life. This is half-life of 6,000 years. So we've been given the half-life, that is 6,000 years. If the initial amount, that is A0, is 200, okay, that's the initial amount, counts per minute, how long will it take for this rate to fall below 10 counts per minute? Now, they've just told us to fall below. They've not told us the the time. Okay, I mean, they've not told us where it's supposed to reach. They've just said below, because they've not said this should drop to 10 counts per minute, just below 10 counts per minute. So what do you do in that case? So what I'm going to do is I'm going to put the amount here, and then I'm going to put the time here. Okay, so the first one we have is 6,000, isn't it? That is 6,000. Now the space might be small, let me make it big. So I'm going to have amount, and then I'm going to have time. Now the first one we are starting with is 6,000. So the half-life at the beginning, the time is 0, right? So when this is divided now by by 2, remember half-life you get to divide by 2, what answer are we going to get? If you divide this by 2, what are you going to get? 3,000. Now look at the half-life. The half-life is what? In this question, 200. Okay, if the initial, oh, that is now I've changed this. You are also not following. So the initial amount we've been given is 200 counts per minute. The half-life is 6,000, so this is going to be 0, right? Okay, 0. Now you want it, divide 200 by 2, that is going to give you 100. The half-life is 6,000, and then 100 divided by 2, that is going to give us 50. The half-life is 6,000. Add another 6,000, that is going to be 12,000. And then 50 divided by 2 is a 25. 12,000, add again 6,000, that is going to be 18,000. 25 divided by 2, that is 12.5. Add again 6,000, 24,000. And then again divide by 2, that is going to be 6.25. Add 6,000, that is going to be what? 30,000. So you've seen, you want how long will it take for the rate to fall below 10 counts per minute. So this is below 10, as you are able to see. So it's going to take what? It's going to take 30,000. Yes, so that is the answer for this one. You can do this, but you might not be able to use it for everything. Like the other questions that we were solving, some of them you can't use this, because for this one we've been given at least some values which are easy to use. You have the amount and the half-life, and then you are just going down like that. But what if they've not given you the half-life? So, or maybe they've not given you the time. You can also find, but it will be a bit of trick. Okay, let's consider the last question here. An isotope has a half-life of 6 hours. So half-life given us 6 hours. And then they've just said what percentage will be left after 24 hours. Nothing else. What percentage will be left after 24 hours. So you can use also the same formula that we used. Okay, let's say we are starting, let's say we have got amount here, and then we have got time. Now, do we know the initial amount? Do we know the initial amount?
Uh,
Okay, so since we are talking about a percentage, I'm going to use, let's say we are starting with 100%. Okay, that's the one I'll start with since we are talking about a percentage. So the time is 0 when you have got 100%. When this reduces to 50%, remember the half-life is 6, so this will be 6. It divides also by 2, that will be 25%. It goes to 12, and then divide by 2, that will be 12.5 percentage, and then this is going to be 18. Again, divide by 2, that is going to be what? 6.25. 18 plus 6, again, that is going to be 24. So you see, after, you are talking about what percentage will remain after 24 hours, so the percentage is 6.25. That is the answer, 6.25. Or you can use the formula A is equal to A0 1 over 2 to the power T over half-life. So the A itself, that is the final amount that you want to have. You don't know, do you, what percentage will remain? So you don't know the final amount, but you know the initial amount. Let's say the initial amount is 100%. That will be 1 over 2. Okay, and then T, capital T, that is 24, small t, that is 6, that is the half-life. So A is going to be 100 multiplied by 1 over 2. How many times can 6 go into 24? 4 times. So this will be A is equal to 100. So just say this 1 to the power 4, that will still be 1. And then this 2 to the power 4, what is the answer?
60,
2 to the power 4.
16.
Okay. So you now, I'm failing to believe that 2 times 2, 2 times 2, okay, that's correct, 16. And so just say 100 divided by 16. That is going to give you 6.25. That is it. This is the amount that is going to remain. You can use the formula.